Hi all, this is Vinay Reddy from team Beta Learners. So as part of Hack-A-Roo Spring 2022 for CS Data Science IT track, we took a project mainly related to image generation from generative adversarial networks. So in short GANs. So let me deep dive into the presentation. So basically, we will be discussing about problem statement, solution, and implemented work, and a conclusion with respect to this solution that we have done. So as part of problem statement, so we took a topic related to generation of images using GANs by training different deep learning models with different types of data sets that are available related to images with context and without context. That means in one model will generate images without any context, and one model based on the context of the input from the user. So the idea is to develop a deep learning model with the available computer hardware like GPUs and CPUs, and to generate more realistic image possible within the specified time and skill set in the commercial grade that is right now available. So coming to the image generation part, so image generation is a set of techniques or aimed to produce a realistic image within the possible um, features that are available within the resources available at that point of time. So generative arts and images are very famous, as now they are mostly converting the generative arts into an NFT and selling them as a non-fungible tokens, which is a trending topic that related to the generative arts that are happening. So in order to implement one such type of implementation, that can be done by deep learning AI-powered generative adversarial networks as GANs. So GAN is an unsupervised learning which can generate images at scale with the following computational powers that are available. So there are mainly two components in a GAN. One is generator and discriminator. So what this generator will do is it will generate the images very similar to the original dataset by creating a small noise as input. That means it will mix the original input with the small noise input and generates the probability of an input and output data. So discriminator in the other side, it will accept the two inputs from the generator, one original image and the generated one, and it will take from the main data set and other from the generator, and it purifies them as real or fake. So until this percentage comes less than 50%, so discriminator will be keep on sending the backward propagation. So it's a forward and backward propagation internally that is happening with variational autoencoders. So this will tell us real or fake. But here we are not defining real or fake, but we are generating an image from the existing image dataset. So as part of this hackathon solution, so our idea is to develop two models which are designed to handle this solution. One is to develop uh, the realistic original images from without dataset without context, and one is taking input from the user, what type of image they need and what context they related to want to generate an image. So those two things we have taken into consideration for generating an image from these two models. So both are different models as they need different training and development. So the images generated by the system, the problem which we are trying to solve, can be used by many people like designers, UI UX designers, artists, NFT developers, and advertisement agencies. The people belonging to these type categories, they can use the images generated by AI to use there as a short-term solutions for their prototypes. So as coming to the first model, so it's a deepfake based image generation. So we are taking a different data set, like it is a celebrity data set which is having numerous amount of lakhs of hundred thousands of more than 100,000 of images of different celebrities that are in the current world, and using that data set we will train a GAN to prepare a face which is not there in the data set and which looks more similar. So as we discussed about the generator and discriminator, both are defined in a way which will allow us to define the model that we wanted to. So in a nutshell, like if I have to explain in the small terms, so we will ask the generator to generate faces without giving it an additional data. So no additional data will be given, only the noise and the inputs from any random image it will be taken, and simultaneously it will fetch all the existing faces in the data set to the discriminator and ask to decide whether the images generated by the generator are genuine or not. So at first, generator will be generating a lossy images, that means which are having little noise, and they will not be able to distinguish easily. Then immediately they will be labeled as fake by the discriminator, because the discriminator has all images that are available in the dataset. So after getting enough feedback from discriminator through backward propagation, the generator will learn to trick the discriminator with forward propagation. As a result, the decreased variation from genuine images cannot be easily distinguished. So consequently, we will obtain very good generative model, which will give us a very realistic outputs with respect to the data set we train. If we train on the faces data set, the faces will be generated. If we generate on birds data set, the birds will be generated. So it is very specific to the data set, but the data can be changed as we need. Only the parameters needs to be considered while developing this model. So the sample input from the celeb A data set, these are the celebrities, and this is the final output from the model one, which is to develop. So this is for after 5,000 iterations, and we need more iterations to develop with less noise, because this needs more GPU computation than the normal one is required. But the images generated are non-realistic, that are nowhere available in the, and this model can be improved further. So coming to the second model, so this is to develop context-based image generation from VQ-GAN and CLIP. So both are GANs that are already predefined by different scientists. So VQ-GAN is a generative adversarial network that is good at generating images that look like others. That means it won't consider the inputs given by the user, but when it combined with the CLIP, which is another neural network, can determine how well a caption is. So in a nutshell, so the user gives like a city during a rainy night. In the first iteration, CLIP will tell no, it is not a city during rainy night, because it do not have any features like that. So all features are stored in the CLIP, and VQGAN will be generating the iterations based on already pre-trained datasets that are available with VQGAN. And once it reaches some level of iterations, and CLIP can identify, okay, this is related to the context that is given by the user by using feature mapping. So this is done in the given image. So the images are given into a generator. So again, generator is a combination of encoder and decoder with all the features that are available. So it will learn and it will create a code book for each type of image that is having, and it will goes to the feature map of visual plots learned within the GAN. So all features are stored in a different, like strokes, circles, rhombus, triangles, all the things that are required for drawing the images. And it goes to the transformer network, which is to learn which will have all the images to combine the feature maps that are created by the generator part, and it will during the long range iterations. So these CLIP model requires more number of iterations than the actual one which we used in the previous. So it's a combination of autoencoders, decoders, and generator and discriminator, and the features are generated from CNN. So it is a combination of multiple deep learning models together formed as VQGAN. So coming to the input, so these are the inputs that we can take from the user. So here we can take the text. So these texts are nothing but what type of image the user is expecting. User can give their own width, height, and model. So this model that we developed as part of the hackathon is capable of handling 5 different data sets like face, ImageNet, COCO. It's a common objects in context, and open images from the ImageNext. So these 5 types of models can be used by the server. So this model is not tuned for entire natural things that are happening, but very specific to limited objectives. So images interval. So for every 10, a new iteration will be created. So we can give initial image that we wanted to type of image, or target images that we want, and seed and a maximum number of iterations. So here width and height reduce it to 100 because of the computational usage that we cannot go beyond that, and the maximum iterations also limited to 1,000. Generally, it should be more than 5,000. So these are the images that are generated after 100 iterations. So we can see the images when I give face, we can see the eyes and the nose and mouth that are generated, and this is the image of the GIF of the total images that are generated during the process. So it's an iterative process. We can see the face features that are getting added slowly. This is only with 100 iterations. If it is 1,000, it can generate exact face that we are expecting to be generated by this model using VQ-GAN and CLIP model. So these are the input and these are the outputs for the respective model that we generated with VQ-GAN and CLIP. So the data sets for the implementation, we have used Celebrate dataset, ImageNet, COCO, common objects in context that will have all common objects segmentation, and the objects identification that are already done in the real world. And we have faces HQ, which is a flicker faces HQ dataset, which is similar to syllab A, but it has all common types of faces that are not available in the syllab A dataset. And we have WikiArt and Flickr 30K. So this Flickr 30K is also an important one, which we used to detect the face, because this standard benchmark for sentence-based image description. So all the images that are in this Flickr 30K are sentence-based, they have segmented. So they have proper sentence meaning with an image tag. So they can be used for context-based image generations in an real-time environment. So for developing the prototype, we used Google Colab. It's a collaborative research environment from Google for deep learning, and framework PyTorch. It's an open source machine learning framework developed by Facebook Research Lab. And the language we used is Python. And coming to the conclusion, so both models showed the archetype of the image generation with realistic features. Due to limited computational usage of GPU, the models are trained for limited time. So the models can further improve by increasing the training period, and which is a scheduled task and running in the background. So which we are gathering the loss percentages on the model generated. So these models later will be deployed with fast API and enable user interface at a later stage of the implementation, which users can select from UI to give what type of image they need and what type of size they want and how many iterations they can be done. So due to limited global usage of GPU, the model has been not yet deployed. We are still working on the UI implementation part. So these are some of the research papers that we have gone through, like VQ-GAN and the existing implementation of face recommendations, face generations, and some of the references related to datasets and the language that we used. Thank you.